Hello, everyone. Welcome once again to the Center for Operations Research and Data Science, CORDS. My name is Kwame Ade. I'm the founder of CORDS and director of CORDS. I double as the assistant professor of business analytics at the Minnesota State University, Moorhead. In today's video, our objective is to describe the distributions of passenger ticket class and passenger survival of the Titanic dataset using the DPLYR and V3 packages in R. Secondly, we will also examine the association between two classes of variables in that same dataset using the Cramer's V from the SG plot package. So before we delve into the codes, I'll briefly describe the situation and then the data set. So I'm sure a number of you have watched the Titanic movie, and this is something that happened in 1912. So the RMS Titanic sank when it struck an iceberg in the early hours of April 15th, 1912, killing more than half of the passengers and crew aboard. Now, the data set you are going to use for this particular exercise contains demographic information for 887 of those passengers, as well as a record of whether or not a passenger survived. So these are some of the variables we'll be looking at in the data. So the variable names are shown here where we see survived, and survived indicates if the passenger survived the sinking or not. And then we represent it as a numeric variable. P class represents the passenger class, whether the passenger was in first class, second class, or third class. The name represents the passenger's name, which is a string. The sex of the passenger or gender of the passenger being male or female. And then we see the age showing here. And then we also see the number of siblings or having a spouse aboard the vessel. And then we also see the number of parents or having children aboard the vessel. And then we see the ticket fare paid in pounds. So this is how the data looks like. So we can now move on and go into our R. Okay. So before we begin this exercise, so let me enlarge this a bit so that we can see all the codes. Okay, good. So in the first place, I'll talk about the packages that we'll use for this particular exercise. So we'll first want to install the DPLYR package. And I'm sure a number of you are familiar with this particular package. So for those of you who are not familiar, this particular package provides a consistent set of verbs for data manipulation. And some of the libraries you can find in it are the mutate library, the select library, filter or summarize and group by. Now, the next package you install is the SG plot package. And what the SG plot package does is it summarizes our models by creating publication-ready regression tables with standardized coefficients, confidence intervals, and significance stars. Also, it can help you generate tables for your data set and cross tabulations. And in this particular exercise, we'll focus on the cross tabulations. So I'll not talk about the several other functions that it can perform. Then finally, the next package we will also install is the V3 package. So what that package does is that it helps create a hierarchical relationship among variables in your data. And it can also create variable trees by displaying the counts and proportions for categorical variables in a tree-like structure. So we are going to harness that advantage of this particular package. So right away, I'll delve straight into the the codes. So in line 10, what I do is I call in the data, and the data is in the CSV format. So I call in the data and I name the data as Titanic, and I use read.csv, and this is the directory of my data. So I call it in, and then the next thing I do, so let's look at the data and just be sure that we have the data. So if we look here, we see that we have the data showing here. So we can look at the data and be sure that we have those variables in there. So we are seeing the variables we mentioned: survive, P class, name, sex, age, siblings or spouses aboard, parents and children aboard, and then the fare paid. So we know that we have this variable in there. Okay, so the next thing we want to do is, with the variables we saw, we want to generate a new variable which would be a string variable. Because if you looked at the survive variable, it was a 1 or a 0. So what I do here is I create a new variable called survival classification, and then I set an if else condition. And then based on the if else condition, I say if the variable observation is 1, it should be changed into a string variable called survived. And then if it is 0, it should be changed into a string variable called did not survive. So I do that. And then I then go ahead and use the mutate library from the dplyr. And then similarly, I convert the P class observations from numeric to string. So here I say if P class is equal to 1, convert it to a numeric called first class. If it is equal to 2, convert it to a numeric called second class. And then if it is equal to 3, convert it to a numeric called third class. So that is essentially what I do. So I run that one here. So then it's time for us to look at some results. So what I do next is I want to use the SJ plot to prepare a cross tabulation so that I can look at how many passengers survived and how many did not survive. Then it can also help me look at within the different classes, what was the survival. So in first class, how many survived and then how many didn't survive. In second class, how many survived and how many didn't survive. And then in third class, how many survived and how many didn't survive. So when I run it, I can now print it here. So when I print it, we can look at it and then see our results showing here. So from the results, it is telling us that in all, 545 passengers did not survive. And then it tells us that 342 passengers survived. So this is the total. But then we come into the breakdown and we see that 80 people did not survive among the 216 first class passengers, whereas 136 of them survived. When we look at the third class, we are seeing that 368 did not survive out of the 487. That looks like a huge proportion. So that could beg a question that was it that those who were in first class were favored? That's why only a few of them did not survive compared to the number that did not survive in third class. So the good thing is that the SG plot can allow us to conduct a Cramer V test. Now, the Cramer's V test has an advantage because it is able to determine the association between two categorical variables. And because passenger class is a categorical variable and then survivor class is a categorical variable, we can go on and then run a Cramer's V test. So for us to run the Cramer's V test, I just make a simple change. If you see in this first line, I said false to show summary. However, for me to see the Cramer's V test, all I need to do is to change this one to true. So I change it to true and then I go ahead to print it. So then we come here and we can see the results of the Cramer's V test here. So we are seeing that the Cramer's V tells us that the model is statistically significant and the Cramer's V is 0.338. So what is the decision rule for the Cramer's V test? So I'll go ahead and show the decision rule for the Cramer's V test here. Now, even though I'm going to show you the decision rule for the Cramer's V test, what you have to bear in mind is that there are different classifications, but then the popular and the standardized one is what I'm going to show you. So this is the decision rule. So if your Cramer's V is below 0.1, then what we say is that there's a weak association between those two categorical variables. Now, if it is between 0.11 and 0.3, then we say there's moderate association. Then if it is between 0.31 and 0.50, we say there's a relatively strong association. Then if it is above 0.5, we say the two variables have very strong association. So because ours was 0.338, what we are seeing here is that there is a relatively strong association between passenger class and survival classification or survival. Okay, so now that we've been able to test and we've seen that there's a relatively strong association between those two categorical variables, we can go on and then plot some visuals of it. So to plot the visuals, we will use our V3. So in our V3, we call in our passenger class and we call in our survival classification, and then we plot this particular plot here. So we see this gives us a very nice, this gives us a very nice plot. So we are now seeing that among the 887 passengers, 216 of them were in the first class, 184 of them were in the second class, and 487 of them were in the third class. And then the cool thing is we also find there are percentages here. So this is 24% for first class, 21% for second class, and then 55% for third class. Now, among the first class passengers, how many survived and how many did not survive? So what we are seeing here is that 37% of the first class passengers did not survive. 63% of the first class passengers survived. Now, if you look at third class, we see that only 24% survived and then 76% did not survive. Now, I decided to present that V3 as a vertical graph. So why don't I look at it from a horizontal perspective and see how it's going to look like? So all I need to do is change this horizon here to true. And then for the sake of differentiation, let me just change these colors. So I run this and then we check this and we see that this time, this is how it looks like. So this is now a horizontal version of the class and of the classes or the classifications, and then it presents the same information for us. Now, another way we can visualize this is by using the ggplot. And of course, the ggplot is popular and a lot of you do know the ggplot. But let's look at it from this and see how it's going to look like. So what I first do is I again use the dplyr package to count the observations or get frequencies of the two classes I'm concerned about. So this is what I do. I run this and then I say summarize their frequencies. Then once it has summarized their frequencies, I go on again to do the same labeling I did previously for this new data set, which is called Titanic 1. And then furthermore, I label passenger class by converting the numeric observations into string or character observations. So I just need to check and be sure that those codes did run. So Titanic 1 is shown here, and you are seeing that I have the frequencies for each and every one of them here. So since it did work, I can go on and run my ggplot. So in my ggplot, I call in the data set, which is Titanic 1, and then I fail by the factor survived and the passenger class, those two variables, and then I let my y-axis be the frequency. So I'll run it and then we can see how it looks like. So when I do run it, this is how it looks like. So we can see survival rates by class. So this is showing first class, this is showing second class, and this is showing third class. And the frequencies are showing here. Now, I can just change the variable and then have this, instead of showing as numbers, have their actual names here. So in this second code, I change the variables and then I do random. So let's see what the graph is going to look like. So over here, having changed the variables, I now have, and I can see this one here as first class, second class, and then third class. Now, another thing I can do is change the structure of the graph. Instead of having first class, second class, and third class, I can decide to look at the proportions within survival. So let's look at it from this perspective. So from here, I'm looking at the proportions within survival status rather than the proportions within passenger class. So again, I'm seeing here that this is for those who did not survive, and um, this shows the proportion that did not survive for third class, and then this shows the proportion that survived for third class. Now I can definitely convert this into their actual names by changing the variable name. So having changed the variable names, this is what I get. So I now have did not survive and then survive. So this is how you can perform some descriptive statistics from this data set, and it gives you a fair idea of what the proportions are, and it also helps you to be able to test the association between these categories. Thank you very much for your attention.